All right, so in this video, we're going to look at how we compute decimal numbers that are raised to power, that have exponents. So the directions say simplify 4/10 to the third power. So my first hint or first step that I think you need to do is write this out in expanded or factored form. That is the first thing I would do, is write it out the long way, factored form we call it. And remember that 0.4 to the third power, it basically means 0.4 times 0.4 times 0.4. Now that we have it written out in the longer form, there's a few ways we can handle it. The first thing I'm going to recommend is we just work two factors at a time. So we're just going to go left to right. We're just going to deal with the first two factors, which is 0.4 times 0.4. And we're going to ignore the decimal. We're going to pretend there's no decimals and that it's 4 times 4. So if we just do that, 4 times 4, I'm going to do it off to the side here. 4 times 4 is 16. And we have one digit to the right of the decimal in our first 4, and we have one digit to the right of the decimal in our second 4. So in our product, we need 2 digits to the right of the decimal. So I'm going to take the decimal point on the end of that number past the ones place, and I'm going to swoop it in 2 places. And then I'm going to come back over here and I'm going to write it down. So just kind of thinking through it over here. Could have done this mentally, but I wanted you to really see that decimal transition. So it's 0.16. Those first two factors, when you multiply, give you 0.16. And then I'm going to write times 0.4 again. That's this one that I haven't done yet. So I'm funneling. Now I've just got to do the last piece. And remember, in our multiplying lesson, you learned that to multiply 1600ths times 4/10, you would start off by just rewriting the problem as two whole numbers, 16 times 4. And then off to the side, you would say there were 2 digits to the right of the decimal here. There's 1 digit to the right of the decimal there. And then you would multiply 6 times 4, 24, carry the 2. 4 times 1 is 4, plus 2 is 6. As if there's no decimal, you do that multiplication. And then we total up, now that we're done multiplying, we total up 2 and 1 is 3. I need 3 digits to the right of the decimal. So I'm going to start on the end, and then I'm going to swoop in 1, 2, and 3. And when I do that, I get a 0 that I've got to fill. I'm going to put my decimal in. I've got to fill this hole with a 0. And I end up with the number 0.064. And if you want, you could put a 0 in the ones place just to hold that, make it real obvious where your decimal is. And that gives you your product. So that is one way to handle it. Another way to handle it is just to rewrite this problem itself as 4 times 4 times 4. And then you can put how many digits are to the right at the top, and you can just tweak it when you get down below, because this is really a mental math problem. 4 times 4 is 16. Bring down your times 4. 16 times 4 is 64. And then now we add this up. There are 3 digits to the right in this problem. So now I swoop 1, 2, and 3. Fill that hole with a 0. So you can work it out. If you can do it mentally, this is how you would show your funneling. And if you wanted to do it with the funneling, which is required, you could do this work just off to the side. Either way is fine. So you put it in factored form. Your second step is to go ahead and ignore the decimals, ignore the decimal points, and then swoop them in at the end. So you multiply as if there's no decimal, like they're whole numbers. And then your third step is to adjust decimal point according to how many were to the right in the problem. All right, let's look at another example. Let's look at 0.1 to the 4th power. So I'm going to write it out first in that factored form, the long way. 0.1 times 0.01 times 0.01 times 0.01. You're going to watch how easy this is, but it's also very easy to make careless errors. So the decimal point at the end is huge. So I'm going to just write it in factored form. Now I'm going to write it as if there's no decimals in it. So I'm going to just write it as 1 times 1 times 1 times 1. I'm going to indicate up top that there are 2 digits to the right, 1, 2. This one also has 2 digits to the right. This one has 2 digits because it's the same factor over and over again, 2 digits. Now I'm going to multiply. 1 times 1 is 1. Funneling, 1 times 1 is 1. 1 times 1 is 1. I get 1. But I now need to swoop my decimal. 1, 2, 4, 6, 8 places. Holy Toledo. 8 places. So it starts here and I got to go 1, 2, 3, 4, 5, 6, 7, and 8. Oh my goodness, this is a really tiny number. I'm filling 7 holes with zeros and I have a 1 on the end. So my answer to this one is 0.1, 2, 3, 4, 5, 6, 7, and a 1 on the end. This is the millionths place, so this is the 100 millionths. 100 millionth. Teeny, teeny, tiny number. Okay, very easy to do mentally. If you write it out, you just go 2, 2, 2, 2, and you go 1 times 1 times 1 times 1 is 1, and swoop at 8 places. All right? So you just got to handle the decimal at the end. You can definitely do the multiplication. A lot of it is mental, but you've got to make sure you adjust the decimal at the end to make it the size it's supposed to be. Let's do one more. All right, this last example, we're just going to do it quick. We're going to write it out the long way so we can count those decimal places. Probably the part where most mistakes are made is that decimal point, how to move it. And then we're just going to take it as if there's no decimal. It's 3 times 3. All right, so when I count here, I've got 1, 2, 3, 1, 2, 3, 3 to the right, 3 to the right. When I'm done, my product has to have 6 to the right. So now I do my 3 times 3 as if there's no decimal. I get 9, and now I swoop it. 6 places, so I have 6 places to move it. 1, 2, 3, 4, 5, and 6. And now I have to fill those holes with zeros. 1, 2, 3, 4, 5 zeros. And so this is tenths, hundredths, thousandths, 10,000s, 100,000s, millions. So 0.003 to the 2nd power is 9 millionths. Again, very teeny tiny amount. All right, so that's how you do exponents when you have decimals. Not too bad. Just make sure you adjust the decimal appropriately at the end. Good luck.